Hello everyone, hope you're doing well today. For this video, we are going to be, again, proving triangles are similar, just practicing. The three methods for proving triangles are similar. There's angle-angle similarity, this is the one that's most commonly used, side-side-side similarity, and side-angle-side similarity. Now, this is the most commonly used. We've already done a video about that one, so you can look at that if you need to. This video is going to be using side-side-side similarity, which says if all the corresponding sides are proportional, then the triangles are similar. This is the second easiest method. Some people find this the easiest, but I find the second easiest. I find it's easy to just find two pairs of congruent angles. Some people, though, think this is easier. We'll take a look. You can decide on your own. So, in order to do side-side-side similarity, we have to find all the sides, all corresponding sides are proportional. Now, if you remember, proportional means they've got the same scale factor, or they're the same ratio. So, we're going to look at this two different ways to check. So, I've got two triangles here, triangle QPR and triangle TSU. Are these triangles similar? Some of you are going to notice this right away and say, yes, they are. Because 3 times 2 is 6, 4 times 2 is 8, 5 times 2 is 10. And you would be correct. These triangles are similar. So the question is, how do we write that? There's two different ways you can do it. First, if you like that whole scale factor idea, 3 times 2 is 6. That's perfectly fine. I will show you how to do it that way. So you can say QP equals 3. 3 times 2 is equal to 6. And that is side ST. Perfect. PR is 4. 4 times 2 is equal to 8, and that is SU. And QR is equal to 5. 5 times 2 is equal to 10, and that is side TU. So then we're just going to say all corresponding sides have the same scale factor. Have a scale factor of 2. We normally use K for the scale factor. I don't know why. I think it's because K is for constant. You may say, why don't we use C? A lot of mathematics was done by German. They don't use C's, they use K's instead. But use whatever you want, but scale factor of 2. K equals 2. All corresponding sides have a scale factor of K equals 2. So, triangle QPR is similar to triangle QP matches up with TS. PR matches up with SU. So triangle QPR is similar to triangle TSU by side-side-side similarity. QED. And we're finished. That's it. You're done. Now, some people don't like to use the scale factor method. They like to use the proportional method, so using proportions. So I will show you how to do that as well. So if we're using proportions, what we're going to do is, first we have to set up our proportion, QP over, well, that matches up with TS. QP over TS is equal to PR over SU, QR over TU, So first we set up our proportion, then we're just going to plug in our numbers and show that it's all the same. 3 over 6 is equal to 4 over 8 is equal to 5 over 10. All those are exactly 1/2. I can even come over here and put equals 1/2. So the corresponding sides are proportional. Therefore, or if you want to use the cool symbol for therefore and don't want to have to write it, you can just write therefore triangle QPR is similar to triangle TSU. And we throw a QED on the end to show that we have finished our proof. Make sure you actually check though. Don't just assume, oh, 3 over 6 and 4 over 8, that's all 1/2. Then maybe you get over here and you see 17 over 36. Make sure 5 over 10 does reduce to 1/2, because sometimes the third side won't be. Okay? All right, so there's 2 different ways to do problem number 3. I'm going to go ahead and try number 4. If you want to pause the video, you can do that and try to figure out your answer. I'll give you a few seconds to pause the video, and then I will go on with this and show you how I would do it. Okay, so number 4. Let's see here. Now this one's not quite as easy. You got some larger numbers. It's kind of difficult to tell. So let me check here. 24. Well, that's the smallest side. I'm going to match up the smallest side and the smallest side. So 24 over 30. And then let's check out. Let's see here. The second smallest side would be 25 and 32. 32. And 28 and 35. The largest sides. So I put small over small, medium over medium, big over big. And let me check here. I can put a little question mark above these because I don't know if they're equal yet or not. And let me put the sides down too, just so we can say what we're talking about. So GF over DC. 25 is FH over CE. And then GH over DE. Okay, let's do some checking here. Well, I can divide this both those can be reduced by 6. So I'm going to get 4 over 5. Is that equal to, can I reduce 25 and 32? You know what, I can't. This can be divided only by 5. This can be divided by 2, 4, 8, and 16, but I can't reduce that. 25 over 32. If I divide this by 7 and this by 7, that reduces to 4 over 5. So I've got 2 pairs of sides that have the same ratio, the same proportion, but this third side does not. Okay, so triangle DCE, or let's go CDE, is not similar to triangle FGH. All three sides have to have the same ratio. If you were to figure this out as a decimal, this would be exactly 0.8. And this would be exactly 0.8. This would not be exactly 0.8. It'd be very close, but it would not be exactly 0.8. So that's how you do it. If you want to figure out what number to multiply, so 30 times what number gives you 24, turns out it's 0.8, and then check 32 times 0.8, does that give you 25? You could check that. Let's do that real fast. 32 times 0.8. For example, 30 times 0.8, 0, 24, move the decimal over 1, 24. So that one worked out just fine, right? 32 times 0.8 though, well, that's 16. 25.6. So that side's just a little bit too small. So there you have it. Two different ways to prove triangles are similar using side similarity. You got to check the small side to the small side, medium side to medium side, large side to large side. If you need to, plug into a calculator. 4 divided by 5. Is that equal to 25 over 32? And you'd find no, it's not. It's going to be like 0.79 something. It's not equal to that. These are equal, but you got to have all three. All right. Thanks for watching.